Okay, so the next topic worksheet is going to cover sections 3.5, 3.3, and 3.2. And problem one is kind of a matching problem. I've got these graphs on another handout for you. Match each graph to the function. So part A, let's see, is going to be the square function. Part B is going to be the constant function. Part C is going to be the square root function. Part D is going to be the absolute value function. Part E is going to be the identity function. Part F is going to be the cube function. Part G is going to be the reciprocal function. And part H is going to be the cube root function. I've got the answers to all those below. Problem 2. The graph of y equals x squared plus 5 is shown to the right. One way to obtain this graph is to apply a shift of the graph of y equal x squared up by a distance of 5 units. Okay, so we know that the graph of y equal x squared is centered at the origin, so I would have shifted up 5 units. Suppose that we would like to graph y equal x squared minus 5. One way to obtain this graph is to apply a shift to the graph of y equal x squared down 5 units. Okay, so the graph would be down here. In general, if we want to graph y equal f of x plus k, we can start with the graph of y equal f of x and shift k units up if k is positive, as in this case, and shift k units down if k is negative. Okay, so problem 3, the graph of y equal x, the absolute value of x minus 8 is shown to the right, and one way to obtain this graph is to apply a shift to the graph of the graph of y equals the absolute value of x to the right by a distance of 8 units. Okay, and of course the original graph of y equals the absolute value of x is centered at the origin, so it would have written to the right. Suppose that we would like to graph y equal x squared, y equal the absolute value of x plus 8. One way to obtain this graph is to apply a shift to the graph of y equal the absolute value of x to the left, 8 units. In general, if we want to graph y equal the f of x plus k, we can start with the graph of y equal f of x and shift k units to the left if k is a positive, as is the case there, and shift k units to the right if k is a negative, as is the case right here. K is a negative. Okay, problem 4. Write the equation of the graph shown to the right, shown below. Here we got to do something with y equal x cubed. I would have went 1 unit to the right, and okay, so I got to add 1 then to the function, and then I go 6 units up. So y equal x plus 1 cubed plus 6 is negative 1 6 is where the center of the graph would be. Write the equation of the graph, whose graph is the graph of y equal the square root of x, but is shifted down 3 units and then to the left 7 units. So if I go down 3 units, I have to subtract 3. And if I go to the left 7 units, I need to add 7 underneath the radical. Going to the right or to the left is kind of backwards from how we're used to thinking of it. going to the right means that I shift to the a negative amount, and going to the left means I'm shifting a positive amount. Okay, like here I get the square root of x plus 7 minus 3. One way to graph negative x is to reflect the graph of y equal to the absolute value of x about the x-axis. Okay, and I can see that. In general, if we want to graph f of x, y equal to negative f of x, we start with the graph of f of x, and we reflect this graph about the x-axis. Problem 7, part A, the graph of f of y equals the square root of negative x is shown to the right, and one way to obtain this graph is to reflect the graph of y equal the square root of x about the y-axis. In general, if we want to graph y equal the f of negative x, we can start with the graph of y equal f of x and reflect this graph about the y-axis. So that's what I've done there. I would have started with the graph in quadrant 1, and I would have shifted across the y-axis. Okay. Problem 8. Write the equation of the graph shown below. So here I would have reflected about the x-axis, because I would have started with y equal x squared. Okay. And I would have reflected about the x-axis and then shifted up 7 units, it looks like. Okay. So y equal negative x squared plus 7. Now, I don't want parentheses there, because parentheses mean something different. Problem 9, write the equation of the graph shown below. Well, I reflect about x, and then I go to the left 5 units. Okay, so I gotta use parentheses to indicate that I've gone to the left. If I did not have parentheses, it wouldn't mean the same thing. If I had negative x squared minus 5, negative x squared minus 5 means that I'm down here. Okay. So the point is that I got to have parentheses when it's necessary. Okay. Problem 10, write the equation of the graph shown below. Okay, so here I'm starting with the square root function, and of course the original graph is in quadrant 1. Looks like I've went down 6 units. So I've got the square root of x minus 6, and then I reflect about the y-axis, so the square root of negative x minus 6 is the answer. Okay, problem 11. The graph of y equals 2 times the absolute value of x is shown to the right. One way to obtain this graph is to apply a vertical stretch of the graph of y equals the absolute value of x by a factor of 2. This means that you would multiply the y values of y equals the absolute value of x by 2 in order to get the graph of y equals 2 times the absolute value of x. So check it out here. That's what I've done. Of course, the absolute value function is v-shaped, and the v is creating a 90-degree angle right at the 0, 0. So 0, 0 is on the graph, 1, 1 is on the graph, 2, 2 is on the graph, negative 1, 1 is on the graph, negative 2, 2 is on the graph. Okay, I'm multiplying the y values by 2. Okay, so 0, 0 is going to stay right at 0, 0. Negative 1, 1 goes to 1, 2. 2, 2 goes to 2, 4. Okay, negative 1, 1 goes to negative 1, 2. Negative 2, 2 goes to negative 2, 4, etc. In general, if we want to graph c times c times f of x, and c is positive, then there will be a vertical stretch of the graph of y equal the f of x by a factor of c. This means that you would multiply the y values, that's all I'm doing here, of y equal f of x by c in order to get the new graph y equals c times f of x. So that's all I'm doing. I'm multiplying all the y values by 2 to get the new graph there. Okay. Problem 11a. Graph of y equals 1/2 times the absolute value of x is shown to the right. One way to obtain this graph is to apply a vertical shrink of the graph of y equals the absolute value of x by a factor of 1/2. This means that you would multiply the y values of y equals the absolute value of x by 1/2 in order to get the graph of y equals 1/2 x. So check it out. 0, 0 is on the graph, 1, 1 is on the graph, 2, 2 is on the graph, negative 1, 1 is on the graph, negative 2, 2 is on the graph, etc. All I'm doing is multiplying the y values by 1/2. So 0, 0 is going to stay on the graph. 1, 1/2 is on the graph. Okay. 2, 2, when I multiply the y value by 1/2, that puts me at 2, 1 on the graph. Negative 1, 1, when I multiply the y value by 1/2, that puts me at negative 1, 1/2. Negative 2, 2, when I multiply the y value by 1/2, puts me at negative 2, 1 on the new graph. Okay, and we call this a vertical shrink. Okay, if you imagine hands pulling on the y-axis, shrinking the graph down, smashing it, we're shrinking the graph. In general, if we want to graph y equals c times f of x, and c happens to be a number that is between 0 and 1, there will be a vertical shrink of the graph of y equals f of x by a factor of c. This means that you would multiply the y values of f of x by c in order to get the new graph of y equals c times f of x. And that's all I'm doing. I'm multiplying all the y values by c in order to get that new graph. If negative 7, 4 is on the graph of y equals f of x, then which of the following must be on the graph of y equals 3 times f of x? Well, all I got to do is multiply the y value by 3. Okay, so negative 7, 12 is on the graph. Okay. Problem 13. Use transformations to sketch the graph of y equals negative 2x squared plus 3. So I'm going to start with y equal x squared, which I've got graphed. And then here's y equals negative 2x squared. Y equals negative 2x squared means that I've got a vertical stretch along with a reflection about the x-axis. So 0, 0 is going to stay on the graph. 1, 1 goes to 1, negative 2. Negative 1, 1 goes to negative 1, negative 2. 2, 4 on the original graph would go to 2, negative 8. And negative 2, 4 will go to negative 2, negative 8. Okay, and both those are off the scale that I've got there. Plus 3 means I go up 3 units. Okay, so 0, 3 would be on the graph, 1, 1 would be on the graph, negative 1, 1 would be on the graph. And that completes the drawing. Y equals negative 2x squared plus 3. Okay, we'll look at one more here. Y equals f of x is given below. Part A, let's sketch the graph of y equals x plus 2, f of x plus 2 minus 2. And then part B, we'll sketch the graph of y equals 1/3 times f of x. Okay, so y equals f of x plus 2 minus 2 means I got to go to the down 2 units and to the left 2 units. Okay, so all these points have to go down 2 and to the left 2. Okay, so here's 4, 0. When I go down 2 and to the left 2, that puts me at negative 2, 2, negative 2. When I go down 2 and to the left 2, there, that puts me at 0, 1. And when I go down 2 and to the left 2, that puts me at negative 2, 1. Right here, when I go down 2 and the left 2, it puts me at negative 6, negative 5. And so I've got that new graph drawn there. Nothing changed. It's just been shifted twice. Okay. Part B, sketch the graph of y equals 1/3 times f of x. Well, all I would do is just multiply the y values by 1/3 to get the new graph. And that's going to cause a vertical shrink of the original graph, since 1/3 is between 0 and 1. Okay, so here's 4, 0. When I multiply 0 by 1/3, I get 4, 0. Here's 2, 3 on the graph. When I multiply 3 by 1/3, I get 2, 1 on the graph. 0, 1, 0, 3 on the new graph. When I multiply the y value by 1/3, that puts me at 0, 1 on the new graph. Negative 4, negative 3, when I multiply the y value by 1/3, that puts me at negative 4, negative 1. Okay, and here's negative 2, 0. When I multiply the y value by 1/3, that doesn't do anything with negative 2, 0. Is going to stay right at negative 2, 0. So I want to make sure that this line segment crosses at negative 2, 0, if possible. Okay, and here'd be my answer then. Okay, so let's stop right there. We're not done with this sheet yet. We've got section 3.3 and 3.2 next.